Question number 6. So a 30-kilogram block is moving down on an inclined plane of angle 20 degree. So the coefficient of kinetic friction between the block and this inclined plane is 0.20. So we have to draw a free body diagram to show the forces acting on the body, and lastly determine the kinetic friction force acting on the block. Okay, so again, let me just, I forgot to put a dot here for my previous solution, right? Should I try just make it bigger? Let me try. Boleh lah tu. Okay, so let me just take my axis. Okay, so we have an axis. You don't really have to draw the axis during exam. Just make sure you see that they are x and y component lah. Okay, so let me just draw the the forces. Okay, so there is a velocity, maksudnya the object is moving. It is moving down on inclined plane. Tapi dia tidak cakap pasal whether the velocity is... Oh, it's okay. We are just looking at the y component anyway. Alright, now, so the... Well, actually, this sorry, bingung pula tiba-tiba. Okay, I'm just gonna draw it on this diagram lah, sebab our axis will be balik juga, sebab it's easier for us to draw the free body diagram lah, macam ni. Okay, so it's gonna be somewhere here. So okay, now we are gonna draw the forces. Okay, usually students would firstly draw the line of the weight macam ni, mg. So this is not how you draw the weight punya direction. It is gonna be, it will be pointing down. Apa-apa pun dia mesti point down. Jangan kamu pandai-pandai pergi lukis dia miring-miring. Dia tidak pernah miring. Dia sentiasa tunjuk pergi bawah. And then we have our normal force. So this is our normal force because it is in contact with the inclined plane. Next, since the motion is to here, we have to there's a friction force that is opposing this motion, so it is pointing in the opposite direction lah. Okay. So this angle here, this angle 20 degree here, sorry, bukan this angle, the angle will be equal to 20 degree. Okay. How did I get 20 degree? Macam mana saya mau explain? Okay, how do I get 20 degree is if I put another axis here, another line of axis at this point here, and we draw the same thing at this point. So this is the weight. Okay, and then we have this thing here, then here. Okay, so now our component macam mana explain lah? Kejap ah. This is the thing. So now if we look at this, apa nama dia yang trigonometry tu, yang if this one, yang ini akan sama dengan yang ini di sini. Berapa ni nama dia? 20 degree. Lepas tu yang sini pun will be 20 degree. Damn, how did I explain to the students? Macam mana saya boleh dapat 20 degree tu? Lupa saya macam mana. Did I forget something? Oh, okay. So now this is a 90 degree juga. 90 minus 20 is 70 kan? Then we have 90 minus 70 is equal to 20 degree. Macam tu. Alright, so that is how you get that is how I know 20 degree to di sini. Begitu. Okay? Alright, let me just padam this thing because this is confusing. Alright? That's all. This is not the class. I can't ask you. Okay, so this is mg, this is n, this is the kinetic friction force. Did I forget anything? I don't think so. Okay, so that is all the free body diagram lah. Actually, let me extract this. Yeah, macam ni. So, your free body diagram ni macam ni lah. Oh, don't forget your dot because I always forgot to put the dot here. Okay, so itu representing the object. Okay, so that is question A. Question B, we have to determine the kinetic friction force. So this kinetic friction force is only in our bukan only in our y-axis. How you calculate it is the formula is equal to mu k n. Okay, so coefficient of kinetic friction is given, which is 0.20. So kita perlu cari apa? Kita just perlu cari the value of n. So n, we are gonna take the y component as this part here. So this is our y component. Our x component will be this part here. Okay? Basically, because it's easier if we do it this way lah. So this is our x component and this is our y component. The one yang the normal force. Let me just label that. So this is y component ataupun y-axis. So this is our y-axis. This is our x-axis. Okay, so this is our x. This is our y-axis. Okay, so now let's look at the y component. So at y component, there is no motion. There's only motion in this x-axis. So that's why we cannot use x-axis because we do not have the acceleration value ataupun the velocity. Okay, so that's why we are gonna focus on the y component. Lagipun sebab kita perlu cari nilai n. We don't have anything in x-axis that can help us to solve this value of n. Okay, so total force at the y component will be equal to 0 because it is not moving in the y component. So what is in the y component? It is n minus mg cos 20 degree. Okay, so why did I not use sine 20? Because kalau saya darab dengan sine 20 degree, mg ni will be at the x-axis. It won't be on the y-axis. Okay, value tu bukan di y-axis, value tu di x-axis. That's why kita guna cos 20 degree. Because kita mau nilai yang di y-axis. Right? So this will be equal to 0 and is equal to mg cos 20 degree. So m is given as 2 kilogram. Is it 2 kilogram? I don't really remember. Pandai-pandai je. 30 kilogram na. So 30 kilogram, 9.81. This is cos 20 degree. And we have the normal force to be equal to... Astaga, dia tidak bagi pula di solution. I have to copy it. Darab cos 20 degree. So that is 276.55 Newton. Okay, so from here we can then use this to solve for kinetic friction force. This is 0.20, 276.55. So you will get 55.31 Newton as the answer. Alright, so that is the solution for question number 6.